Hello, everybody. Welcome to the Neo4j Online Meetup. Thanks for joining us, whatever time of the day it is for you. So for those of you who haven't joined one of these before, I do a little bit of logistics for you. So we've got Dimitri here with us today. So we'll do a little bit of an introduction to him in a minute. He's going to be showing us a tool that he's built called InfraNodus. Hopefully I said that correct. And he's put a link to the tool on the right-hand side on the chat. And I can include that in the comments as well for those of you watching afterwards. So you're welcome to have a look at that. There'll be some code shown in this talk. So you'll need to make sure that your resolution is high enough. In the bottom right-hand side, you can click on the little button that says settings with the little HD icon on it, and put yourself at 720p so that you can view everything. So with that, I'm gonna introduce our guest today. So Dimitri, as I said, has built a tool called InfraNodus, and I came across this while searching for Neo4j repositories. And as the title of the talk says, it does text network visualization. But I guess I'll hand over to you, Dimitri, and let you explain a bit more. Maybe you can introduce yourself and maybe explain the tool to everybody.
Thank you, Mark. Hello, everyone. I'm Dimitri, and I work on InfraNodus tool, which is a tool that allows you to visualize any text as a network. I've been doing it already for maybe 6 or 7 years. I kind of got into it just out of pure interest, but now it became an obsession of mine. And I use InfraNodus at the backend, Neo4j at the backend, and Node.Js as well. Most of it is written in JavaScript, the front-end stuff. And yeah, I want to show you today how this tool works. First, starting with showing you the capacities of the tool, what it can do, so you can see somehow how it works and what are the features that are needed. And then I'm going to go into the backend and show you how it's done, the database model I use, and how I use Neo4j to make this tool work.
Cool. So you've been doing it for 6 or 7 years. Have you been using Neo4j all of the time as the start?
Yeah, in fact, the first iteration of this tool I did was called TextTexture. It's still online. It was done on PHP and MySQL. And very quickly I saw the limits of this, because when you're dealing with millions of nodes and millions of connections, it was just very slow. And it looked like there was no way to actually develop it further. So that was in 2011. I stopped. And then 2 years after, I came across Neo4j. And then I thought, okay, I'm going to give it a try and also see if I can go through these limitations that I encountered with MySQL, and it worked. It was quite good. I mean, I also had some problems with Neo4j as well, but so far it's been the best database that I could find for what I need.
Oh, cool. So must be into your 5th year of using Neo4j. So I guess you must have picked it up maybe in the 2.0 series or the late one.
Late one.
Late one series. Oh, cool.
1.9 or something like that. Yeah.
And now we're on 3.3, nearly 3.4. So it's quite a different experience now than it was when you started.
Mm-hmm.
Cool. So how I guess maybe one more question before we get onto the tool. Yeah. How did you come across it in the first place? So you had this limitation of the current stack, and how did you know there was an alternative?
Yeah, so in fact, I was working on another project, which was called No Nodes, at a school where I was doing masters at the time, and they used Neo4j as a backend database because it was about building a graph of knowledge. So I kind of came across that database in that context, and then I thought, okay, this can be something interesting to try also for InfraNodus as well. So I did some tryouts, and it worked, and also, I just want to mention that what was amazing is the community behind Neo4j, because each time I had a question and something didn't work, I would just go on Stack Overflow, and I had a lot of help like that. So I really appreciated how fast it was possible to get something done and resolved if I had a problem, which was really great.
Cool. Yeah, I think I had a similar experience before I started working for Neo. So used to be asking questions 2 or 3 on a Friday night in the morning, and Michael Hunger would be straight in there with the answer.
Yeah.
Okay, so actually that reminds me of something that I forgot. If you have any questions that you want to ask Dimitri, you can ask them either in the YouTube chat if you're watching this live, or if you now, alongside the Stack Overflow, we also have the Neo4j Slack. And so we have a Neo4j Online Meetup channel. So if you search for Neo4j users Slack, if you're not already a member, and if you go in there, there's a Neo4j Online Meetup channel, and you can ask any questions there. And Dimitri and I will try to help you with those questions. So for now, I'm going to hand control over to Dimitri, and let's have a look at InfraNodus. Again, if you have any questions, let us know, and I will ask them for you live.
Okay,
cool.
So I'm going to switch to the screen sharing right now. Can you see the screen?
Yep.
Great. Okay. So I'm going to start the presentation now from showing the tool itself, how it works, and then I'm going to go into the technical details. So InfraNodus is a tool that allows you to create text network visualizations to store, develop, and connect your ideas. I'm going to show a few examples of how it works so you just can quickly understand what it's about. So for example, a feature that I developed very recently is the visualization of the news of the day. It takes RSS feeds from different news sites. You can actually customize in the settings which news sites you want to use. And then it visualizes you what people are talking about at the moment. So you can kind of see the main topics. Like in this case, I think it's a visualization from sometime in the middle of April. And it's talking about Trump. And you can also click and see which news it is, open the news, and so on. So it allows you to do that. You also have different other topics in the news as well. You can click on them, see different sources that talk about these topics. So as you can see, InfraNodus can be used not only to visualize the discourse that's happening at the moment, but to also quickly look into the different aspects of this discourse, find the specific parts of the text which mention these search terms or mention these words. It's a little bit like a tech cloud, but I call it tech cloud 2.0 because it shows you not only the most frequently mentioned words, actually it shows you words that have the highest betweenness centrality. So this is where the graphs come in, but also it shows you words that are used together in the same context, which you don't have in normal tech clouds. So you can see here that, for example, the word Trump is used next to North Korea. So you can quickly find the part of the text which is talking exactly about this subject. Now we can move back. I'm going to show you a few more use cases.
By the way, we have question number 1 already, but you may well get into this, so feel free to delay your answers. So the question was, what JavaScript library are you using for the visualization that you just showed?
Yeah, so it's a very important part of InfraNodus is that it uses sigma.js, which was written by my friend. Yeah, it's a really good library. I mean, it works quite well for a lot of nodes and edges. It's very customizable. I think he's working on the third version now. His name is Alexis Giacomi, but you can find it on GitHub, sigma.js. Is there any more questions?
Not at the moment. So the words that you have in that visualization, do you pull out every word from the articles, or are you pulling out some specific ones, or how does that
just the
work?
titles and the description of the news? I think in this case it was just the titles actually, because I tried with a few different options, and already the titles give you quite a lot of information, because newspapers and news media, they're really motivated to give you as much information as possible in a title. So it's just titles. And I think it's about 5 sources: Washington Post, New York Times, Guardian, and some other newspapers. I kind of tried to make a mix of different ones, also with a different ideological standpoint and so on. So you can have like a representation of what all the different medias are talking about.
Cool. Yeah, I've seen some people do stuff where they try, rather than pulling out all the words, they look for specific entities. So for example, there's a library written by some folks from GraphAware where they're doing entity extraction, and they're building a graph of just the entities rather than having all the different words. So it's interesting to see the 2 different approaches.
Yeah, this one relies much less on the semantics of the text. I mean, actually, it's word co-occurrences. I'm going to mention later how it works. But I found it's interesting also because it kind of it can also visualize any text. It's very easy to make this work in any language. At the moment, it works also in French, in German, and in Russian, because you don't have to analyze the entities. You can just visualize what words occur next to each other, and then you can quickly see in which context they're used together. Okay, I'm gonna move on to show some other use cases. For example, we also have a visualization of a longer text. Let's try to find it here. This is the same one. For instance, here's a visualization of the Bible, first paragraph. So you can also visualize longer text using this tool, and then you can start reading them in a non-linear way. So you can select some nodes inside and see what it's talking about: Lord, wife, man. And then we can see the passages from the first part of the Bible that talk about this stuff. You can also select other words and so on. So this is just a quick introduction to what it can do. It doesn't only analyze texts. In fact, you can also visualize entities. So for instance, here is a visualization of the different philosophers. So you can use hashtags or underscore to kind of make connections between different entities. It doesn't have to be only text. It can also be names of places, people, and so on. So you can create all kinds of graphs with it. In a way, it's a tool that allows you to put into a network graph any sort of textual information. Going to go back now and explain to you a little bit how it works. Can you still hear me? It works?
Yeah, sorry, I was muted, but yeah, all good.
Okay, great.
We've got another couple of questions for you.
Yeah.
So, do you do anything with TF IDF on the graph? You mentioned word co-occurrence, so maybe.
No, I'm not using this algorithm.
Okay.
Yeah, I'm aware of it, but I'm going to explain now how it works. Is there two more questions you said?
And then there are a couple more. One of them is, what's the application for this beyond just using it as a tag cloud to explore? And then the second one is, could you use this for doing live real-time semantic analysis of language?
Yeah, so the use of that, actually, there is a lot of different ones. First of all, you can identify the main topics in the text and the relations between them, like I just showed. You can also use this tool to learn new stuff. So for example, the way that I've done it before and the way that people use it is when they make a research, they put in different quotes and notes that they make, and gradually you accumulate a lot of data, and you can see how all these notes and different pieces of ideas connect. So this can be really good for learning, because you can see what are the topics that you've been interested in for a while, and also what are the structural gaps in the graph. Then another use tool is for writing, actually. So you can also, if you need to write a text, you can again make some notes and kind of put it all into a graph, visualize it, see how it all connects. I'm going to also demonstrate some more specific use cases later. Like there's one where you can actually use it for search engine optimization, where you can import Google search results, visualize to see what is the discourse available for the search terms you're interested in. And then you can identify the gaps in this discourse. So if you see that people are searching for, let's say, graph databases, and then you can see in the graph that there's a connection missing between two different clusters of this graph, then you could maybe introduce some content which would talk about these ideas. I've also done some experiments using this tool to give visual feedback on a dialogue, on a conversation. So you make an interview and then you visualize it as a graph. And as you're speaking, you start asking questions that connect different parts of the graph together. There are actually articles available on all of this on noduslabs.com. So here is a use case for using it for psychotherapy, for instance. And this image, I think you can see it, it shows how it works, but I described the whole methodology in the article. You identify the clusters of text, and then you start asking questions that connect different clusters of the graph together. And it provides for, first of all, a very interesting conversation, because people, they have this eureka moments a lot when you ask them questions that connect different parts of discourse that they just exposed to you. And also it allows them to see what they're kind of hiding or not revealing automatically. And you can find this research on noduslabs.com. And what was the third question again?
One sec. No, I think you've done all of them. So there was TF-IDF, then there was applications. So you've just done that. And then the other one was, could you use this for doing semantic language analysis?
Okay. Yeah. I'm going to show now how it works from a more technical perspective, so people can also see what is the algorithm behind and how it works. In fact, it's also an open source tool, so there's a repository on GitHub, and everyone can go in and see. I explain in the description of the project how it works as well on there. So I'm going to go into the tool itself. Also, by the way, if there are any questions, I will sometimes make breaks, so don't hesitate to interrupt me and to ask them. I think it's good to answer as they arrive. All right?
Yep, will do.
Okay, great. So now I'm going to show you the way that this algorithm works. In fact, there is a feature inside where you can use voice input. So I'm going to talk into the tool, and you will see gradually the logic behind it. This is a word. This is a phrase with a few words in it. So as you've just seen, when I say a word, it becomes a node in the graph. And when there is a phrase that has several words inside, then they become connected. The algorithm works based on co-occurrence of words. So when the words are next to each other in a certain window, so they don't have to be right next to each other, but maybe 1 or 2 words in between. In fact, there is a gap of 4 words following landscape reading model. So when these words are used together in the same context, they're visualized as being connected in the graph. So each word is a node. Each co-occurrence of words is the connection between them. I will continue speaking into the graph so you can see a little bit more. When there is a few more words in a phrase and I talk about something else, then this graph is going to grow. So as you can see now, we have many more nodes. I'm going to make a special setting that you can see all the labels of the nodes like this. It's going to be clear how it works. Then also, if I say now something completely different that uses a different vocabulary, it's going to appear somewhere else in this window. So as you can see, I said something else that used different vocabulary, and now we have 2 graphs. Now, if I say a phrase that has both the word vocabulary and window and the graph, then these 2 parts will be connected. So as you can see, this is a quick demo of how it works. You can also, of course, type things in, but using a microphone gives you a really nice visual feedback on how we actually create meaning when we speak, when we use language. The words occur together, and then those connections start to make sense as soon as they become interconnected into certain clusters and entities. If I say something now about vocabulary, for example, and use the word island, then I can say that these 2 are connected, and this island is the island of topics that are used in the text. Yeah, sometimes it thinks that island is Ireland, actually. It's the Google voice recognition software that does that. And I just said this kind of like slightly meaningless phrase because I wanted to show you what happens when we start adding the discourse, which uses words which have not been used before. What happens to the graph? I'm going to do one more phrase now. If I talk about an island that has a lot of trees and that has a sea and different palm trees and beaches, then you will see it will make a new picture on the graph. So you can see now we have the new nodes on the graph, which are kind of connected into a different community and so on. So this is basically to demonstrate you how it works. Each word is a node. Every co-occurrence of words is the connection between them. Then you have the graph, and then on this graph we have communities identified based on the modularity algorithm. So here you have an analytics pane that shows you the three main communities of words in the graph. So first one is word, graph, and vocabulary, and you can select them and click and see the words which use the sentences which use these words inside the graph. And then you have also the second topic, tree, okay, here. And then the third one is where I was talking about the island and how things are connected. They create an island together. So basically it visualizes the main topics inside the text by identifying communities in the graph. And then we have the most influential words, which are the words that have the highest betweenness centrality in the graph. So it's the nodes that appear most often on the random paths between any randomly chosen, on the shortest paths between any two randomly chosen nodes in the graph. And here it's the words island and graph are the most, they have the highest betweenness centrality. I will talk about the rest of the analytics later. First, is there any more questions so far?
No new ones since the last ones you answered.
Okay, great. So I'm going to move on and show you some other aspects of the tool. For instance, what we can do also, now I just showed what happens when you type in your own information, but you can also visualize any new one. There's a special bookmarklet that allows you to do it. So for example, here I'm on the page that describes this talk, and I'm going to select this description and click on the bookmarklet here. Just a moment. So I choose the text, select it, then we go and paste it in the tool. Then it's gonna visualize it as a graph. So here we have graph representation of the text which is describing this meetup. You can also quickly see what are the main topics inside by selecting the nodes in the graph. It automatically selects the part of the text which is talking about these subjects here. What you can also do is compare two different texts together. So for example, if I wanted to compare this graph to the graph of the text that I just created before, I can click this button on the right here to compare different graphs and then click on the one that I want to compare it with. And what's interesting is that it shows me here, we can read it in the analytics pane, here it explains which words or nodes exist in the new graph, in the meetup graph, but not in the original text that I created. So here the two most relevant ones are network and metaphor. So in a way, I could say that originally I promised to speak about network, metaphors, and weave, but in the text which I just made in the beginning, when I was demonstrating how it works, I didn't mention any of these terms. So what you can do using this information, actually, you can also see what happens when you combine two different discourses together and how they contribute to each other. So here we can see that the description of the workshop, it was talking about the network and metaphor. So maybe we're interested to kind of learn more about the subjects. And here we have different ways to do that. For instance, I could, of course, go on Google. There's a button that just does the Google search on this network metaphor. So you kind of leave the graph and you go into the outside world to see what exists out there. But as you can see, there's a lot of search results. So if you feel too lazy to read through them all, you can just also import all the Google search results into the tool. There's a feature that allows you to do that. I'm going to save it into the Google. We already have these two search terms here, and we press the button. It's going to take a few seconds because it imports about 40 or 50 different results, I think. And here we have visualization of the Google search results that are shown when we search for network metaphor. I'm just going to make this graph a little bit more readable by showing nodes only for the biggest labels here. And then, of course, also, we know that the search results will talk a lot about network metaphor. So the tool has a feature where you can add some nodes into a list of stop words, so they're not shown on the graph. In order to do this, I select them and then click this delete button, and they're removed from the graph. So now I see what are the nodes that would be most influential in the graph if those two most influential ones didn't exist. So now we see that definitely social media is something that's mentioned a lot on Google alongside network metaphor search queries. So we can see that, okay, it's talking about social network analysis and how it's used in media studies. Okay, so we get some new information about maybe where this research would be interesting. We can also look for some other stuff and, for example, see what are the other most relevant topics. I will add these two nodes into the stop words. Okay, so we can now see that there is something about visual promotion. So basically it becomes a tool to analyze search results, which can be interesting for writers because it can give you some ideas on what you could write in relation to the subject. But also, if you do search engine optimization, it allows you to identify structural gaps in the existing discourse and see where you could come in and fill in this discourse with some relevant information. All right, I will.
Got some more questions for you.
Please.
So first one is the betweenness calculated in the browser or on the server side?
So yeah, that's a good question. In fact, now it's calculated in the browser, but I tried also to use server-side algorithms by using graph algorithms of Neo4j, and that also works great. The only limitation that I found was that, as you can see, you can manipulate graph live, and it automatically recalculates everything. So, for example, when I add these words back into the graph, which I just made which were just deleted. I'm just going to show you from the beginning. So what happens now is that we have the graph and we show bigger the nodes that have higher betweenness centrality. Now, if I select them and remove them from the graph, what happens is that it automatically recalculates the whole statistics on the graph, and it shows which are the nodes that have high betweenness centrality now. So because of this live aspect, I decided to kind of delegate it to the front end. But in fact, I'm also working on the API now, and that's going to use Neo4j because it's quite fast. It's just for the front end, I didn't think it was necessary. And also using front end allows me to experiment a little bit faster with how it should be displayed. But I think once I come to some concrete ideas of how it should be represented and so on, I'll probably use backend, because then it could be used for the API so that others could connect, load the text in and then get all the data, and you wouldn't need to use front end for that.
Okay, cool. And then the second part of that question was, is there a limit on the number of words you can have in a single context?
So in fact, right now the limit is set to 150 in the settings. This is the default limit, but let's say let's put 500 for instance and see what happens. In fact, I really don't know if it's going to work. The reason is that in fact, you don't really have a limit, but if you have more than 80 or 100 words, readability of the graph really suffers, because it becomes very visually complex. So I found that around 80 to 100 nodes was somehow digestible. You can still use it as a tool. When we have now 313 words in the graph, I think this is the number of words that were actually in this Google search queries. You see that it already becomes quite complex. And in fact, you just get absolutely the same insights on the data, because we still have, if we remove these two words, we still have social as the most influential word inside science, so you kind of you lose out a lot of these peripheral nodes, but for research purposes, they're not so interesting. So yeah, it doesn't have a limit. But it's just going to be less readable, and also it's going to be slower if you visualize, let's say, 2000 nodes or something like that. Then if you have a computer that's not so powerful, it's probably going to lag a little bit. And I also don't want to encourage people to use so many nodes, because then server side, it might also add some traffic, and it will need more processing power.
And then I think so. Somebody was asking, is there's a place where you can sign up to use this, or like what's the way that people could use this if they're interested?
Yeah, they can. So basically, the way that it works is that they can go on InfraNodus.com and sign up for an account. In fact, they can also go to GitHub and download the whole thing and install it on their own server. That also works fine. It's an open source free project. The thing is, when they sign up online on InfraNodus.com, it's kind of limited, because I don't want too many people to use it at the same time, because it's also in the beta stage. So I need to kind of get the feedback from the users, and I'm working on it alone. It's not financed by anyone. There is no investors and so on. So basically, I prefer to have this personal relationship with the users, where I can develop the tool together with them and for them. So they sign up, they fill out a form, I receive it, and basically, if they can offer some kind of contribution, then we make the arrangement, and then I send them the invitation code, or they can pay a little donation, and then they get the invitation code immediately, which helps me support the servers and so on.
Cool. Well, you might have a few people registered after this.
Okay, nice.
And then last, I wouldn't say, it's probably more a statement than a question, which is, this changes my life. So
oh, really?
That's some nice feedback.
Nice.
Cool. Anyway, I'll let you continue.
It would be interesting to know in which context. So maybe if this person can elaborate a little bit more while we speak, that will be interesting to know. Because then we can make this change even more profound if we know which direction to work in. So it will be great. Now we stopped at the visualization part of Google search results. I showed you how you can also manipulate this graph live. So basically, you can remove the nodes that you're not interested in seeing. Automatically, everything gets recalculated and so on. Let's say now let's give it a little bit more complicated task. For instance, I'm going to show you how you can also visualize the Wikipedia article. Maybe if anyone wants to analyze like a Wikipedia page, a specific page, they can just write it into the chat. And I'm going to go on Wikipedia and choose one. But if you see someone writing something,
yeah, come on, people, this is your chance to completely influence what happens next.
For now, I'm just gonna Maybe actually something on graph databases. I'm interested in this stuff. Okay, so this could be an article. Do we have something coming?
Wisdom of crowds is a suggestion.
Okay, let's wait for one more.
I suppose we could do the Cypher query language if we wanted to.
Okay. Wisdom of crowds is an article in Wikipedia that people thought to analyze, right? Okay, so let's try this if it arrived first. So I'm just gonna select it, and then there's a feature inside InfraNodus here, import. In fact, you have also like the homepage, and you can also go into the import from there. And then I choose here any web page, Wikipedia article. So I select this article and copy and paste it here, and it's going to be saved in the context graph that's called Wikipedia. I also have a few settings here. This is if you really want to fine tune how the tool works, but we don't need to do it right now. So then I click visualize. Here it's going to take some seconds because it's a long text. It takes some time to process it. In fact, also this is one limitation I'm currently working on, is how to make processing much faster. I'm going to talk a little bit more about graph model that I use later, and maybe there are some problems in that, but for now, long texts take quite some time to process, maybe 30 seconds, 1 minute. I would like it to be more instant. So I'm going to talk about this a little bit later, and if anyone has ideas how that could be improved, it would be really great, because this.
So what's happening once you run that? So it goes to the Wikipedia link, it downloads the page, then you're doing some sort of parsing to pull out some tokens, or how does that next bit work?
Yeah, so basically how it works is that it goes to the Wikipedia page, takes all the text from there, and then the first thing it does is that it removes all the stop words from that text. So words like is, the, a, articles, and so on, prepositions and stuff like that, only leaving the words that really carry meaning in the text.
So are you using any library for that, or is that like custom stuff that you wrote?
No, I think the stop words part is really simple. Like I just have a file of stop words, and it just searches through, and gets rid of them. Then the next step is a library actually, which does lemmatization. And that was really hard to find. Now I use something that was adapted from a very good library, which was called PHP Morphe. It was written in PHP, and this is the original one I used back in the days in 2011. But this PHP Morphe one, now they have a Node.Js port of that, and that's a really good library. I saw that it was really hard to actually find the lemmatization module, because if you go on GitHub and search for any modules, there's a lot of options, but they all do very simplified morphemes. So basically maybe I should explain what
Go ahead.
lemmatization is. Yeah, because basically it's just bringing all the words from the future and past into present, and plural becomes singular, and so on. So for example, if you said crowds and then crowd, then it becomes crowd. If you say answered or will answer, it just becomes answer, how you have it here, and so on.
So are you storing the lemmatized version in the graph?
Exactly, yeah. Okay. So the whole text is saved, and then the lemmatized version of it actually is what goes into the graph. So each word becomes a lemma, and it becomes a node in the graph. And then when these lemmas occur next to each other, they become strongly connected. Like, for instance, in this case, you see that crowd and wisdom, they have quite a strong connection. It's also shown quite thick in the graph. By the way, you can zoom in and out also. And yeah, basically it's because these two words in this article on crowd wisdom are obviously used a lot next to each other. But for instance, you have another one that's argue, and the connection between crowd and argue is not so strong, because it was used next to each other, but they also had some distance in between. So then the connection between words becomes weaker the further they are from each other. All right. So there is a gap of 4 words. There's actually 2 scans. One that scans all the words that are next to each other and then makes a graph from that. And then on top of this graph, we add another graph where you scan the gap of words in 4 lemmas together. So the closer they are, then the better it is. I tried with a lot of different settings over years, already like almost 7 years I've been playing around with that, and I found that this algorithms works really well to produce meaningful data that you could then interpret later. By the way, you can also change it in the settings. So you can say that you, there's a setting somewhere here. Yeah, like you can say that only show me connections next to connections. It means only connections between the words that are next to each other. And near connections means scan in this gap window and so on. So then the next step is that after we have this graph of the lemmas, I record it into Neo4j, and that's quite a long search query. Maybe I'm going to show you.
Do you store the full raw text of the document, or do you only store the
Yeah, no,
words that you pull out?
yeah, I also store the whole text of the document as well. Yeah, so basically there is the whole text stored and then the separate graph representation of it. But it's stored, in fact, yeah, now it does this thing again, sorry. It stores as a series of statements, as you can see here. This is actually limitation that I encountered with the way that I use Neo4j, because each query that is done, I will show you how it's constructed in the code. Basically, I mean, yeah, this is a query to add a statement. It generates ID for every statement. For every word, it has to generate a new node. Then it also makes connection between this word and the statement where it appears, and then also the context where it appears and the user that makes it. So in the end, you end up with quite a long query. I think, let's say 80 bytes of text become about 80 kilobytes. And this is because my search query is quite long and I really want to work on reducing it. But I'm going to show you the data model I use later. So maybe if anyone has ideas how, this could be improved, it would be really great, because at the moment I have to put the text in short statements, which is kind of good, because then when you search for different stuff, you really can quickly do the search. So there's some advantages of that, but also it would be great to be able to put in longer texts inside. Yeah, so then the graph is created, it's visualized as a network, and yeah, then we can start analyzing this graph, getting all the statistics and so on. For example, here we have the second part of this stats on the graph is something that I call polysingularity index. And basically it shows how biased this discourse is. It can be really interesting for researchers who want to analyze bias in discourse in text. The way it works is that it detects modularity of the graph. So if the community structure of the graph is quite pronounced, then it's going to have several distinct communities which will be separate from each other but still connected, but not too much. So in this case, we actually have focused, and that means that the community structure in this text is not really pronounced. So you have some communities of nodes, of words, some topics, but most of them are in only one. It's this orange one, smart crowd wisdom. And also it detects how the most influential words are spread in different communities. And for example, here we see that that they're spread quite well, but the community structure is not so prominent. So because of this, this text gets the focused score. Let's say if we remove these nodes, crowd wisdom, and maybe also some other key ones, like let's say we get rid of the individual and maybe also prediction and market. You see it recalculates the stats. So now it becomes diversified when we remove these keywords, market, prediction, individual, wisdom, crowd. we see that the text would get a new formation. It would become more diversified. It means it would have different topics which would not be so related between each other, and that maybe present different points of view. So it can be really useful when you analyze news like that, because even with the headlines, you can see that sometimes they're focused on one subject and sometimes it's diversified and sometimes it's biased. And biased is when really all the key terms are in one topic and you see that they're trying to push an agenda. So it can also be used to analyze discourse or any graph and to see how biased or how diversified it is. Is there any more questions so far?
No questions.
Okay.
We've got another statement.
Yeah.
Fantastic. Just what the doctor ordered. I've imagined something like this for years. So
Nice.
another good feedback. That's from Thomas Friesendahl.
Great. Thank you, Thomas. And I'm going to show further maybe some technical aspects. Basically, also, one last thing I wanted to show about the way the tool works itself is that you can really quickly click on the nodes and see which parts of the text talk about these nodes. You know, so you can start reading this article in this nonlinear way. You see that also the main topic inside, for instance, if we remove crowd wisdom, it's talking about prediction market. So let's see what they want to say here. It's the most common application of the crowd wisdom is the prediction market. So we can quickly see and get insights on a long text. And it's not a replacement for reading this text, but think of it as just getting another point of view, another perspective, another way to look at this text, to read it in a way that you wouldn't read it normally, maybe. So it's just like a tool to stimulate your imagination and to make you think a bit differently, and to introduce this graph thinking framework into the way that we read texts and events in general. I also wanted to take the time that we have left to show the graph model I use in the backend. So here is the GitHub page of the project.
Maybe one question before you go on to that. What other websites do you allow people to pull in data from? So you showed Wikipedia, you showed Google, and then the question is, can we pull in Facebook posts or tweets?
Yeah, so basically, yeah, right now you can pull any web page. So I just give you some examples here that you can just like main page of the Guardian site, the Wikipedia article, but you can actually choose any page and then you enter the URL here and it's going to visualize it. You can also really adjust the settings. So which classes, which HTML classes from the page you want to pull in. So you could really play around with the tool and see how it works. With Facebook, I'm not sure if they allow access right now because of all these problems. And in fact, the kind of content you would get from Facebook is not that interesting because people just write about, I mean, if it's a page, maybe, or if it's a meaningful discussion, but it would be much more interesting to pull in data from comments. For instance, if a company wants to learn the sentiment about its product or a forum, then this could be possible if you put in a page here and you say that you want to visualize a certain class on that page. But in fact, the users that have access to the tool, they can tell me what data they want to import, and usually I will implement this feature in the priority queue. So if someone is kind of using the tool actively and they tell me I won't have access to the data on this forum or in this command system, then I could implement it. It's quite easy to do. You just need to make a parser that would understand the specific pages.
Cool. Okay. Guess I can go on to the.
Yeah, here you also can import Twitter, so you can do like a visualization of Twitter, let's say like top tweets in English with the hashtags.
Do the Neo4j hashtag.
Yeah. I just was thinking to do that.
It's very, very self-referential.
Yeah, but why not? Neo4j, and then you choose save it in the new context. Okay, I'm just going.
I hope people are saying nice things. Otherwise, it's going to be an interesting graph.
Yeah, it's just going to show the 200 most recent tweets that are happening right now. It takes a little bit of time to do. Right. So here we go. So here we have
Cool.
the whole graph. I'm just going to remove Neo4j from it so we don't have that noise. And then we see, okay,
What have we got?
yeah, so we can see that people are talking about a graph data bloom. Let's
Bloom is a visualization tool that was announced yesterday. You can see
okay,
it on your left-hand side.
great. So yeah, we can see that quite a lot, and you can actually also yeah, like click on the tweet and then see what is the actual link that's talking on Twitter about this subject. We can also select some other stuff. Like I see that Graph Tour is also a prominent node.
Yeah, that's an event that's happening in the US at the moment. So doing lots of
Okay.
different conferences in different places in the US.
That's great. So you
So
have
that's a good
that.
one as well.
Yeah, and then you also have a read fast. What's that?
Well,
Ah,
that seems to be about like workloads. I think that's from a talk that Philip Barathly, who's the third person or second person tagged on there, did yesterday.
yeah, and it's talking about Neo4j 3.4 and how it works faster
Yeah,
than previous versions. So yeah, I mean, you see, this is an example of how it works. Um, you can also, by the way, do the same import, but with the people who actually who made the tweets. So you have, let's say that you say top tweets in English, but and you show originating Twitter accounts, but you can also exclude them or only make a graph of Twitter users that do that. So you could also
okay.
visualize the network of the tweets. So it kind of becomes like a social network analysis tool. In a
Yeah.
way, yeah, it's like a text analysis tool, but in fact you could use it also to analyze social networks as well if you use hashtags and the @ signs.
It's really
Okay.
cool. Yeah, we got another question for you.
Yeah, please.
I'll read it as it is, and then we can check
Yeah,
with you. So, for enterprise data, not public data, can you use this on premise? Which I'm assuming you can, because you could download it and deploy it on your own.
exactly.
Or,
Yeah, yeah. So there's a repository for this on GitHub. You could just there's all the installation instructions. You can install it on your own server and use it there if you need to protect it. And also, of course, if you need assistance with that, you could contact me as well, and then we can talk about it and so on. I guess you would need some separate agreement with Neo4j. If you use it for commercial stuff, then you would need to install the database by yourself. I don't know actually which version would be suitable in this case. Do you know?
I mean, I expect whatever you're using seems to be working
Yeah,
fine.
but
But
would it work on the community version, or you would need to install enterprise if you have to do it for some corporate?
I think it depends on the
Okay.
specific use case.
Yeah.
But it can't really generalize it. But yeah, I mean, certainly to play around with it, they can go to the GitHub repository
Yeah.
and just try it out. I've put the link. If you're interested, if you are watching this live, you can grab the link from the chat on the right hand side.
Hmm. Okay. I'm going to show you also the graph model that I use because this can be interesting to some people who are also developing projects on Neo4j. So basically, there is an article here. Let me see. Yeah, so I'm just going to make an introduction. When I started thinking about how this tool should be made, I thought, okay, it has to have a graph structure that would allow it to be quite flexible because you're working with text, it means that you are actually treating every word as a node, but words, they also occur in certain contexts. So for example, it wouldn't be possible for me to save a word and also save in the properties of this word which user added this word or in which context it was added because maybe some people collaborate on the same context. So, it's several users who will actually add this word, or maybe the word occurs in different graphs. So you have to also have several data like this. So I really had to move away from this idea that you have nodes and nodes have a lot of properties, and then you have connections or edges, and edges don't have properties. And in my data model, edges have a lot of different properties, and that was the only way to make it work for something where you can really adjust, which users made the statement, in which context, which concepts they used, in which sentences, and so on. So I'm going to show you how it works. The basic idea here is that when someone makes a statement, you see the little graphics on the screen. Let's say the moon is white, and so the moon is a word, is a concept, and white is a concept. And this yellow thing is the statement. The moon is white is a statement, and those two concepts, they appear in the same statement. So you can see the arrows pointing to that statement, and this is the type of the connection. Uh, in my model, it's the off connection. So I just call it like this. It's the concepts of statement. And then also these concepts are connected next to each other because of this graph algorithm which connects them together. And this is the to type of connection. Okay. So then if the statement is a bit more complex, like the moon is white and black, you will see that there's a connection between the words to and then the connection to the statement itself. Now, if we add into this user, so we have to make the connection between these words, moon, black, white, and the statement to the user, so we can show which user made that statement. All right, so this type of connection is called by, and it goes from every node. And let's say if we have two statements, the moon is round, the moon is white and black, we make them both in the graph. But for example, the word moon, it exists in both statements, so it will have connection both to the first statement and to the second one. So you can kind of see the structure of how it works. When the new connection is made, you can see how the graph structure evolves. Now we also add the idea of a context, because when we make a statement, it's the yellow circle in the graph with the concepts, which are blue, by the user, which is violet. But statements are usually made in a certain context. So it's like the name of the graph, let's say, or even the context of the conversation, if you want. It makes it easier to think of it this way. So there we have a representation of how the whole thing works, how this data model functions. And of course, you can imagine that if we use this data model, each connection has to have properties, because, for example, if we talk about by connections, which connect the blue concepts to the user, these connections will also have properties, which statement they were made in, so which yellow circle, but it will have the code of that statement, and also which context. So like this, we can identify and make search easier. This is why I use additional APOC algorithm tools in my Neo4j instance, because I have to index all the relationships actually, and most of the search is done by relationships, not by the nodes. So here you have this. You can find it on the website. I'm just gonna post. Done by relationships, not by the nodes. Maybe. So, okay, chat. Sorry, you had a question or?
No, we're good.
All right. Yeah, I cannot add the link there into the YouTube. For some reason, it's disabled, but maybe I'm just going to put a link to the data model. Yeah, in fact, all the links are available on the GitHub repository of InfraNodus, so you can find it there. And here you have like a demonstration of how it works, also how it's realized in Neo4j. So you see the same image. You have the violet concept nodes, moon, full, and then InfraNodus is the user. The context is private, and so on. So it actually describes all the connections which are available in the graph and what properties they have. Here we have timestamp, which statement they occur in which context, and so on. And there are some examples. So if you're interested to look at the data model and then see this really long query I have to do to add statements, and if you think it can be improved, it would be really welcome, because at the moment, as I said, for long texts, it's proving to be like a bottleneck, and it's not working so well. But at the same time, it allows me to realize the tool from a lot of different perspectives. So you can use it for texts and add different statements and so on. I'm going to show you also using a live example of the model. So let's say I will just load the Neo4j browser here. And let's say I will add a statement. So this is my local version. I'm going to make a new. This is a new sentence with a few words in it. And I'm going to later see it in a browser. So I add the statement. Then I'm just going to see the ID of the statement. In fact, you have it in the code itself. So then I can show you. So here is the statement. And if we click on the statement, we'll see that we have the context. This is the words and the user called demo. So you have all these connections here. And here it shows you the type of the connection. So you can see how it's realized in Neo4j exactly in the same way. All right.
Cool. I guess we've kind of reached the 1 hour. So if you have any final questions for Dimitri before we wrap up, now is your chance to ask them. I think the stream is a little bit behind us, so we'll give everybody a few seconds.
Okay.
While we're letting anybody come up with any questions, if you liked Dimitri's talk, obviously thanks to Dimitri for taking the time to talk to us. Don't forget to like it on the YouTube page so that other people can find it as well. And yeah, give the tool a try and let Dimitri know how you get on, and give him some feedback on what you think. We have more comments saying this is such a great tool, but no questions yet. I think it might be safe.
Okay. Well, cool. If they have questions, they can contact me and I will be happy to answer. And thank you for having me and inviting me and finding it. It's great.
Yeah, it's really good to have you. So we've got another comment thanking you for the demo. So that's cool. And I guess we'll wrap up there. So thanks everyone for taking the time to watch. If you liked it, feel free to share the link with the video with your friends or colleagues. And we'll see you again hopefully next week for another version of the online meetup. And thanks again to Dimitri.
Thank you. Cool. Thank you everyone.
Thanks, everyone. Bye-bye.